Hi, my name's Bob Grinier, and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this 25th of August 2024, when we will be discussing O-Day of 48 and Co. This will be a short presentation. It is to review some of the outstanding issues with the model and to challenge you to think also about what might be and what is going to be our final working model that I might want to put into 3D or t-shirts or whatever. I would like these things to be settled at least to the best of our ability. So how is everyone? Hi, John Coombs. Great to see you. Jock of Ages. Venom K. Bo Sinclair. Hi, Mike Avila. Hi, Verity Hound. Great to have you here. Corky Goss. Humberto Dias. Shame you can't be around. Artifact is in the house. Space Case also. Wonderful. And Earthworm Jim. Hi, D2105K3. And this side up 12. And that is a very good quorum we have here. So how are we this lovely summer's day in the Northern Hemisphere? Starting to come to the dog days of summer soon. But it's still pretty darn sweaty here in Brno. Looking forward to those of you that will join us in the coming week. Maybe I will see some of you in Strasbourg. I have no idea. It would be great to see you there. And also some may come to Brno and see myself and Paul Harris do things like Lord Kelvin smoke rings and live experiments of Matsumoto and things like that. So lots of things to do. Hi, Paul O'Neill and Rhett Oracle and Kaya CT. Great to have you with us. Okay, so as you know, I had a sort of iterative process to developing the structure, the O structure, and its fractal variants. And a lot of it came from watching the cavitation structure form and structures rather in Suhas Ralkar's ultrasound tank, and also the forms again also in 2017 on the sadly departed Neil Crichton Gold's Lion reactors. Well, when I was looking at this form, it kind of had shades of the kind of sothic triangle, and I wanted to investigate what the sothic triangle form was. And I came across this diagram here, and I get the exact reference I got it from, although I have the book now that it came from. And I think it was Subtle Energies or something like that website. I will put the link there. But this is the diagram, which was on page 150. I've discussed it before. I've even shown a better scan that I took from the book. But the ratio here of 9 units, 4 units, 9 units for the main sothic triangle came out very, very close to what I was observing in experiment, and also the cone as described in the Mobius strip work that was done in the Soviet energetics research in the Cold War in Russia. And so I kind of settled on that, and that is the model that I have been sharing. Hi, Artifact is in Madeira. Sounds lovely. Okay, but before I go into that, I was sent a video today, and I would suggest people go and listen to it, by one Tom Bearden. And I was sent this by Black's Shoe 10. So thank you, Black Shoe 10 on remoteview.icu. So thank you for forwarding this to me. And this is the video. And there is 2 things in here that came out. And one was essentially Tom has this theory that you're always taking away from the ether and then giving back. And if you can make an asymmetric system such that you can generate a flow net in one direction, and he believed that this was what Tesla was doing, then you can essentially extract energy and everything will be settled at the end, but you can actually create a kind of perpetual motion machine. And he had this device called the MEG, and he said that the trick there was to get around kind of hysteresis and basically make some asymmetry in the way the magnetism worked. And it's interesting because I was in a conversation with a very lovely lady who has been following the project for some time, called Carmen Miller, and her father, Wilhelm Mueller, if I can pull this video up as well. Let's see if that will work. I don't know whether that will work. I've got an advert there, so let's ditch that and we'll see. It's the Mueller motor. And you can go and have a look at this video. It's on Fail Forward Research. And let me see if this is going to work. Is it going to work? It seems to be having an issue on this computer, which is not so good. Let me see if I can fix that. But essentially, he was saying that there was something that he found in a pattern, and this would allow for the asymmetry that was necessary to get the MEG working. And I had this 3-hour wonderful conversation with Carmen Miller, the daughter of Wilhelm Mueller. And she was telling me that they got around this kind of back EMF hysteresis type problem in a pattern. It was in a pattern, and the secret was to pot in resin the magnetic islands of the waste product from the mining industry. And that's very interesting because the previous Saturday, I had gone gold panning with my family for a bit of fun. I got a gold pan and some sieves for my son's birthday. And I'd spotted this zone on this river up in the highlands here in the Czech Republic and gone gold panning. And when I came back with the concentrate, I was doing more panning in the kitchen. And I ended up with a few specks of potentially something, we don't know. But the majority of it was this very black sand, which I was able to separate from some of the other particles and just completely make black sand by using a magnet. It's just funny because I had this conversation on a few days after I actually did the whole process to capture this black sand. And by putting this black sand into a resin, you're able to prevent the heating and some of the losses that were typically there in the material normally used in magnets, in electromagnets. Okay, so if you look at this video, and you can go and look at it in your own time, maybe it will play now, I don't know. But essentially, it goes through, and there is an engineer here who worked for one of the two major plane manufacturers, and he's got 3 PhDs or something, and he came in to assess a partially working Mueller motor using a solar charge controller. So essentially they had a battery bank that was powering the motor, and then the Mueller motor, which you can see here, it's got a large metal disc here, and it has, I think, some electromagnets, and these might be the things that had this mining waste in there. It's obviously not playing very well here. This is not ideal, I have to say, but we'll see how we get on. And what they found was, after a period of time, and this is also not very clear, so it's going to be fun. The output from the motor, the generator part of the motor, was feeding the solar inverter and recharging the batteries. So essentially what they were doing is they had the batteries powering the motor, and they had the generation part of the motor acting, in inverted commas, as the solar panels and feeding back through the inverter and charging the batteries. And over the course of several hours, the batteries recharged. So you can see them here, a lot more charged. Okay, so we are going to have an opportunity to investigate this, but this is exactly what, as far as I can work out, is being discussed as what was necessary for the MEG, for the device that Bearden apparently got a patent on. And so if I can find that window again, let me see if I can find that window again. Here. And so one thing he said was critical is this particular device with this particular material that allowed the MEG to work. And if you recall, I did a translation of Sergey Godin's presentation that he gave fairly recently on his latest work on variants of the MEG and the Searle effect type generator, these type of devices that he was doing in Shenzhen, and a previous presentation that he had given where he was talking about the replication, sort of replication of the Searle effect generator. And I suggested that it was effectively creating toroidal moments and that it was doing, by extension, the Aharonov-Bohm effect. Now, in this video, I can't remember where it is, and I will catch the exact place after this stream and put it in the notes on remoteview.icu. But he talks about his MEG, and he talks about securing the patent on the MEG. And what he ends up by saying is the difficulty he had with the electrical engineers at the US Patent Office is that they didn't understand the Aharonov-Bohm effect. And so essentially what he is saying is that his patent relies on the Aharonov-Bohm effect. I think it's exactly the same process that's going on in all of these processes. So I will find that little clip and I will get that for you so you can see it. But it is in this video called Energy from the Vacuum, Part 36, Engineering Physical Reality. And so there's two parts in there that are key. One, and I think we'll be able to precisely describe, I can precisely show you how to extract the material you need to make the right type of one-way type materials for electromagnets. And then he describes the necessary component of having the Aharonov-Bohm effect. I had no idea that that was so key to his device, but now we all know. So that's what I want to say about that. So I want to thank Blackshoe10 for sending that to me, and that was very kind of him. Okay, so back to the order of the day. Okay, so if you recall last week, I went through a number of people that had sent through their thinking on the structure and how it related to the golden ratio, which I really hadn't considered. I was just drawing something from a hydrodynamic, magnetohydrodynamic point of view. But essentially, the core things that informed that were these two images here, the original one from the Lion tracks in 2017, and that led me to draw this basic structure here of what I thought was going on with a magnetic core and some sort of spiral vortex coming in or out, depending on the left or right-handedness of this. And that there was a cone here, and you could see it from the other things. And then it got round to 2019 with the Amarza gas, and we had a similar structure in my mind. You might not see these as similar, but I saw them as similar, with the material only on one side. This is sweeping over to one side, and this on top of this. This is bigger than this. So, you know, but I believe one is a yang and one is a yin in these cases. So the other thing that informed me on the structure at the time, and I didn't have the images ready, because this was actually, this image here was one of two images on O-Day slide 91, okay? And O-Day slide 91, at the time, I hadn't become aware of the importance of Coptic Christians. I just recognized these structures, which were from old Dongolia in Sudan. So Sudan, if you're not aware, you've got the Nile. The Nile runs through Sudan, and it's basically the country that is essentially south of Egypt. Okay, so I think there's 400 to 500,000 Coptic Christians in Sudan, and I had no idea about this at the time. In fact, I only found out that there was Coptic Christians in Sudan, and this came from Coptic Christians when I was preparing this slide for the notes for the last week's presentation. I didn't even know it last week. All I knew is that in Sudan, they had these capitals from columns somewhere, and they helped me understand that in the center of the vortex and the anti-vortex was the symbol of God-controlled power. And that helped guide my thinking from what I was observing physically under the microscope. And you can see in this one, it's aligned in the center. This is offset, and this is aligned in the center. But this one actually has the Maltese cross, or rather the symbol of God-controlled power, the same one you see in Sumeria from a long time before, actually, here embedded. And this is more like the Maltese cross. It's got the bits coming in, okay? And so this is the Maltese cross, this is the symbol of God-controlled power, and this is more a symbol similar to the angels that were the variation, in my view, somewhere between the Christian cross and the Ankh. Okay, so this, you know, it would be amazing one day to visit this particular site, but I think these are the two most famous pillar capitals that are there. So, and that led to the understanding. Now, what I showed was, and you can download all these slides that I'm showing you right now off the remoteview.icu blog, was the work of Robert Hutchings, and I received this on 10th of September 2023. At the time, I didn't really realize the significance, other than, you know, he was saying, oh, you've got a unit here, and a unit divided by 2, and a unit divided by 2 again, to make the 4, 2, 1 structure, and this is standard hydrodynamics. And then I understood this to be D4D, and so therefore there had to be a circle that was centered at the point of these oval circles that had to be of the correct radius to allow 4 of these things across here, and that one would be in the center, and that would give you a pattern similar to this, where you had the 2 circles on the outside and the circle in the core in the center. And so that's kind of basically how I came to this, and the flow patterns coming in here. It's clearly coming in here and winding itself around here. It's clearly coming in here, or coming out of here in this case. And so that's kind of how I derived it. That and some remote viewing. I can honestly say this came to me in the middle of the night. So you know, that's just the reality. That's what happened. And so, yeah, I didn't know much about whatever else was going on here, but, you know, there we go. Now, Tony Gibboni sent me something here, and this was on the 20th of November, and he was looking at the various golden ratio aspects here. And of course, we know that the sothic triangle has a notch in here, and the disruption zone is in this area. And if you recall from the flux capacitor presentation, where we showed the thing that essentially looked like the scream, you know, that image, the actual disruption zone where it appeared to be consuming the copper down here was elongated, the same as it was in the ultrasound cavitation bubbles of Suhas-Ralkar. Now, the interesting thing, again, I will say about the presentation given by Tom Bearden is in this presentation, he talks about Canzius and the Canzius process. And I don't know if you know about this, but Canzius was a guy who was trying to develop a cancer cure, and he was messing around with microwaves and with salt water. Of course, the body is salt water internally. We are saline creatures inside. And he was trying to trigger some things that might be beneficial to dealing with cancer. And he found that he was essentially disassociating water into what Tom Bearden here calls water gas. Now, water gas is a little bit of an interesting phrase because water gas can mean gas of water, i.e. dry steam. And some people call HHO water gas, or a mixture of the two could be water gas. But strictly speaking, he's referring to water gas as in disassociated hydrogen and oxygen from water. That's what he describes. And it's incredibly interesting, this video, because he's conceptualizing. I've never seen this video until this morning. He's conceptualizing the same kind of thing. He calls it something that causes negative energy. And the negative energy unwinds the assembly of matter from the weakest, and his choice of the weakest in the formation of water gas from water, and water gas actually being split hydrogen and oxygen. In this video right here, he's saying that the weakest thing that can be undone by this negative energy is the OH bond, releasing hydrogen and oxygen, which he calls water gas. And he's saying it's undoing that in a way that's much less energy intensive than you would ordinarily need to do. And it's doing it by applying negative energy. Now, if you go further, the implication is you can undo the electron from the hydrogen, the electron from the oxygen, and ionize those atoms. And if you go further, you would able to start disassembling the nuclei. And in many respects, that's extremely similar to my concept for what's going on in the Great Pyramid, for instance, and what's going on when water is lifted out of a singing bowl and possibly in the nuclear siphon. Thank you for the person that's attempted but failed. But anyway, you know, I'm a bit skeptical about that, but we'll see in the fullness of time. But anyway, the point being is that my understanding for the pyramid is that there is a weaker bond that he does not refer to in this presentation that I am referring to in what I'm thinking is going on in the water spout and these different systems. And that is the polar bond between the polar water molecules. And so it's weakening that bond, and the water molecules just fall apart. And how is it doing that? Well, I am believing that it is literally ripping the hidden energy within the matter out. Or it's causing a flux of condensed relic neutrinos to go through, which upsets the energy balance between in the atoms and between the molecules, causing them to separate in a very different way from normal boiling. So whether it's taking chi out and causing them to separate, or it's overloading them with chi so they separate. And I'm minded to think that the destruction is possibly something to do with that. And in the case of disrupting metals, for instance, possibly in the Hutchison effect, that would be maybe causing crystal grain boundaries to separate because they're overexcited on the crystal grain boundaries. The same thing that would occur when you are doing spoon bending. You overexcite and you form charge clusters, which are collections of relic neutrinos with or without electrons or protons or charged particles in there. And so you're causing the normal weak electron bonds, but they're even weaker between two crystal grains, to become super weak, in the same way that polar bonds become weaker in water. And so he's kind of in the same ballpark, but describing it from the application of negative energy. Well, I suppose if you're pulling chi energy out of something and it has to be replaced by the ether, and let's say the ether is this relic neutrino condensate and the chi energy is the flux of relic neutrinos, then that would be the case. I've also described it as depressurizing the local vacuum in that space. Now, I've shown it on the disruption zone on the cardioid infarction. That's the sample that's brass. It was on iron, and on the front side you see a little triangle area. Well, if you go and look at my presentation from ICCF 25, I show that in the background of one of the slides, and it is a hexagonal array, and I've discussed it in another presentation since. So all around that area you've just got a straight brushed brass. But in that area, which is the same exact area where this disruption occurs in all these different experiments that I've shown you, and it's the same as the subterranean chamber in the Great Pyramid, it's causing something to be able to come out and move, and that possibly the matter to just disassemble, as it were. So in this presentation, I would say that Tom Bearden's thinking is as close as I can imagine thinking to be by a third party to my own. And it was for those three reasons I felt compelled to share this with you today. So thank you for listening to that. Hi DIY Projects with Chalksis and John. Hi Farsted, great to have you here, and Stephen F. Wonderful. And Weed Need for DWC. Weed Nerd. Okay, hi 3 as well. Hi Odd1X. And hi Gordon Doherty. It's going to be a short one, not too long tonight, so hopefully you get your beauty sleep. Right, so that is Tom Bearden. Definitely go and see it. Energy from the vacuum. For one, the magnetic particles, I believe, are the same ones used by the Mueller motor that Carmen Miller talked to me for about 3 hours about earlier this week. The fact that the MEG required the use of the Aharonov-Bohm effect, it was critical to its functioning, and I would agree absolutely would necessarily be. And the fact that he is describing a process similar in creating the Canzius dissociation of hydrogen oxygen in water in a kind of similar way to how I'm describing the process, which goes from catalysis and weakening of bonds all the way through to baryon decay. And it's one single tool, and you just dial it up to 11 if you want baryon decay, and you keep it down at 1 if you just want to weaken bonds and turn metal to jelly and these kind of things. Okay, so let's get back to the titled subject of the presentation today. Right. So the other person that I spoke about last week was Gabby Ensign, and he was talking about the phi ratio here. That was also observed by Tony Gibboni here with the disruption zone, or part of the disruption zone. And he was also referring to this structure here by Charlie Zeiss. And I also shared some images by Charlie Zeiss here. And when I'm looking at Charlie's drawings, it really, to me, looks like he's put the points on the circles. So the first circle here is unit 1, and then he divides it by 1.618, and he gets the first golden ratio division here, which gives you a diameter of 0.618, and so forth down. And it looks like he draws from here to here on the full diameter of the structure, and then he extends the line out this way and extends the line out this way. So those people that use CAD software, they'll know about the extend line tool. So it's basically extending the line all the way to the center point here, extending the line to the center point, and that gives him this particular structure where he's saying that this key angle here is formed 76.345. Okay? Well, I thought I would do my due diligence because we have a number of different angles. We have my angle, which is not quite that. We have the sothic angle. We have this angle which is effectively, there isn't the big angle here shown, and it never was shown, and actually we didn't really discuss it. But this angle here came into play when I started playing around with these things. So what I did is I started to try and recreate what had been done by Mr. Charlie Zeiss here, and I will show you that now. So I apologize if this software crashes. It's a little bit buggy because I'm still using the Intel version on the Mac here, and sometimes it just doesn't like doing things nicely. Let's put it like that. Okay, so we will go like this, and we will go like this, and hopefully you will be able to see what I'm talking about. Okay. All right, so here is my basic O structure, and we've also got the sothic notch in there. So you can see that the active zone is over an area here, which roughly goes up to the top of this circle here and starts, in this case, I've got it kind of starting just outside the non-radiating boundary. The non-radiating boundary is a double layer or something similar, and I've argued that it probably goes from this radius to maybe as little as this radius. But that is to be determined in the fullness of time. But the curious thing was, I started off by creating what I thought Charlie Zeiss had done. Actually, before I do that, I'm going to load the backdrop in so you can see. Load my backdrop. And I'm going to go here, and I'm going to go here. It's going to work. There we go. So what you can see here actually is the sothic triangle from the book, which I was referring to here. It's called The Lion Path. You Can Take It With You. Okay, so you can see that the experimentally derived one combined with the natural sothic triangle, and I literally went to Egypt and to Karnak and confirmed that this really is essentially the correct ratio, or within a ballpark, because you know they're carving into stone, and so you've got a line, but you know apparently it was actually described. I mean, if you go to that page 150 in The Lion Path, you can take it with you. It says the sothic triangle forming an ancient hieroglyph for Sirius, Sothis, was constructed by using 22 units long with markers at 9 and 13 units from the start. Then with the cord pulled taut at these markers and the end meeting in the beginning, the triangle denoting Sothis was formed as the drawing shows. The base being 4 units wide and each sloping side 9 units from the corner to the base vertex in 4:9 proportion. See, for example, the inscriptions at Abydos. Okay, so I don't know whether the inscriptions are Coptic Christian or whether they are pharaonic, dynastic, or pre-dynastic, or whether they're just things that tell you roughly how to do this in a museum. It's not clear from the book entry there, but within a ballpark, this appeared to be correct. Anyway, taking what was done by Zeiss, I tried to model this, and I'm going to turn off the background there. I tried to model this on what I thought he was doing, okay? So let's pull that up. Okay. So this is what I thought was going on in the Zeiss model. And in fact, I have a, well, we can work it out. But basically, I could show you the measurements here, and you would know that if you did the maths, you would find out that it really is the scale that I'm saying it is. So I've got a distance there of 763.9162 millimeters. And if I turn that off again and I go over here and we do this one and we look at this, it's 472.1262 millimeters, whatever. When you do that ratio, you'll end up by seeing that it is phi. This is phi smaller than this one, okay? Well, I kept doing that for a while. So you can see if I zoom into here, it keeps going down and it keeps iterating down. It's like I'm a bit closer to my destination, but it's like zooming into a fractal here. Anyway, at some point it doesn't make a lot of sense to keep going. So there we go. There's a lot of circles in there, much more than it looks when you first look at what you're looking at on the screen. And anyway, I then did my line between this diameter and this diameter. I then projected it out to the center line and projected it back to the line that's flat here. And then what I did was I looked at the angle. So I have an angle tool here, and I can click on here. In fact, I'm actually just going to take out the triangle here so that I don't get any confusion by any of the other lines in there. So that is our so-called triangle, designed off what I thought was the Zeiss method. And so I will do our angle here. So the first angle here, what is that? Well, that is not 76.345. In fact, I haven't done that particularly accurately, but 76.7, that's saying. That is not 76.345. Okay, in fact, it's actually 76.72. But if you work that out, it comes out at 26.56 is the opposite angle. So like the third angle. So if I go up here, and like I say, the accuracy is not high on this, but it's 26.6 in this particular view. And I thought, hold on a minute, hold on a cotton picking minute. I think I've seen that somewhere before. And sure enough, when I went back to my presentation that I gave last week, well, blow me if it wasn't the angle that was given by Robert Hutchins. Okay? It was the angle given by Robert Hutchins. Yeah? So, let's go back to that. There we go. So 26.6. Let's go. When I undo these presentations and stuff, it kind of goes a bit squiffy. Where is that now? It's because I'm full screen, but not full screen. Where's it gone now? No. I've lost my excuse me, sorry. Whilst I talk to myself. Ah, dear. It's hidden itself in a window somewhere, and I don't know. Anyone know how to use a Mac better than me? Oh, where have you gone? Where have you gone? Is it that one? No. Give me a second. Right. Oh, I've lost the main display window. That's not very nice, is it? Where have you gone? Excuse me. I'm going to have to load it back in. So, this is very tedious. Right. We're nearly back in the room. So here we go. So we worked out that this method is actually producing not the structure of Charlie Zeiss, it's producing the structure of Robert Hutchins, because it has this 26.6 degrees here. Okay, so to cut a long story short, I actually looked at the construction that was given to me, the construction method, having gone through several other attempts by Gabby Ensign, where I actually started by building it using a 1.272 and then making this length from J to U 2.694 and having this with a radius of 1 and building in there. And it went through several iterations to try and get it correct. And what I ended up with is this. So the Charlie Zeiss version, okay, is where the it's the tangent here. So we're going from tangent to tangent here, and then projecting from the tangent back to the baseline, and from the tangent all the way up to the intersection on the other side. Okay, so when I'm looking at this and I do the angle on this, so if we go to angle now, and I'm going to get rid of the other things that I don't want. So we'll take these three things and we'll just make sure we just got the triangle here. We go to the angle here and we go down to here and we go to over here. And we've got to the precision of this software. If I do it again, and I'll bring up the numerical window. Here, here, and here. We got 76.34. So it would be 76.345 if the software is a bit more accurate. But there we have it. So I proved that my initial understanding of how he was constructing it was incorrect, and that he was constructing it from the tangent here. Now, I kind of know why. It's because if you have a vortex going round, and if we go to the vortex, which was in the previous presentation, if I can find it. My computer's having a few issues. It's very, very hot in here, by the way. It's probably my computer's struggling because of the heat. Yeah, it's kind of like stopped. I'm going to kill a few apps. Right. Oh dear. It's just stopped. It's really hot. It's been another 34 degrees today, but it sometimes gets hotter in the office here. Okay. Okay, it's just literally stopped. I don't have anything now. I'm going to have to reset my computer. Does anyone have any questions at this point in the process? Okay, I've got it back. Right. What was I saying? Oh, yeah. If you are going to have a vortex that goes around the outside, okay, well, you kind of probably have to have it so that as it's shrinking down, whatever it is that's there has to be encapsulated in it. And so if you can imagine, I've got a vortex starting here and it's going round and it's shrinking at the golden ratio. It kind of has to, touching the tangent makes sense, but it isn't really. It's going from the tangent length to the tangent length, which arguably would probably be still the golden ratio, but I don't think that's correct. I think that Robert Hutchins has got it correct, because you are going from the diameter here to the diameter here. So as soon as you start moving in your vortex away from the diameter, the cone is actually shrinking at the golden ratio. And so it will actually, it needs to do that, and it needs to cut through the sphere here, because it needs to end up in the vortex hitting the next mark with the distance between these two, right? So I think Hutchins got this correct. And part of the evidence I have for that is that the Hutchins one is actually closer to the original sothic triangle. So if I put that in the background, you can see here that Hutchins is, much, much closer to the original sothic triangle derived and experimentally derived one. Whereas if we look at the Charlie Zeiss one, it's outside. Okay, so if I zoom in up here, and I zoom in like so, okay, what we have here is Charlie Zeiss's, then we have Robert Hutchins, and then we have the original, which is the same as the sothic triangle, albeit very, very little difference, okay? Because it came from experimental, and then I observed it to be the same as the sothic triangle, basically. So I think that the correct way to go here is to use the Hutchins one, because it is compliant with the golden ratio circles here, and coming in at this point. Okay, so I don't know what you lost there, but the internet died here. So can anyone let me know what the last thing they were seeing? I was talking about the ratios, but I don't actually know when it dropped. If anyone can help me there, what the last thing was that I said. Already started to shrink. I'm not sure I know what that means. Okay. Those were the last words. Oh dear, what did I have on the screen? Oh dear. Yeah, okay, so I get it. Already started to shrink, but I don't know what that was referring to. It is recorded locally, so I can catch it up here. It's so hot in here. Oh my god. The triangle pointing to the right. Okay. All right, maybe that's what let me see if I can do that. So, okay, so we have our triangle pointing to our right here. I don't know quite what I was saying, but essentially I calculated, just to recap, that I thought what I was generating was the Charlie Zeiss method of producing the triangle, and that in Relentless was as such here. Okay, so I thought I was going through the diameter of these spheres, which were progressively being shrunk by the ratio of 1.618. So if this is length 1, this would be length 0.618, this would be length 0.382, this would be length 0.236, and so on, and that would produce our triangle. When I did that, what I found was that the actual angle was the same angle as was given by the work of Robert Hutchins, okay? Because I found that this angle here was 26. Okay, so Robert Hutchins is actually constructing it that way. So I then try to find out from the work of Zeiss what else he may have meant, and by looking at the diagram of Gaby Ensign here, he had a length here of 1.272, and that's between T and U at the bottom, and from J and U it had a length of 2.694, and from doing that I was able to, with several iterations, get to a point where I could derive how Charlie Zeiss had produced his structure, and that was with the tangent. So he was going from the tangent to here, from the tangent to here, and then extending that back. Thank you, Gary Johnson. That's very useful. For those people that donated last week, thank you very much. I understand the sample is on the way. I don't know whether we'll have time to book a session, but we've nearly got enough money to run it as soon as possible. So I need to find out where that is with the post service. Thank you very much, Gary Johnson, for your support there. Okay, so that goes all the way down, and it's basically tangent to tangent, okay? And then that gives us the correct angle here, the 76.345 that he says is the important angle, okay? Well, putting that together, it isn't correct compared to the original. And if I put in Robert Hutchins is bigger than mine, and Charlie Zeiss is even bigger. So I think the closest thing that is compliant, in my view, with the golden ratio and the correct way for the spiral to go in, and I'm looking for your opinion here, is the work of Robert Hutchins. Okay, so if I go now to the calculated ratios of this, the original one was from the Lion Path with the 9 and 4 and 9, and that is approximately the same as I derived from experiment, and that ratio is 2.25. The actual ratio from my experimentally derived one is 2.286 effectively. It's a little bit bigger by this much, and if you divide that by that ratio, it's 1.573% out. It gives these angles here, 25.26, 77.37, 77.37 to 2 decimal places. In the Hutchins one, it's at 2.17, so it's below. So, and I've gone on. Mine's above, and his is below. And when you do the calculation, it's actually more out. And you get the 26.56, which if you round that to 1 decimal place, it gives you 26.6. That is the angle that he shows on his diagrams. But this is golden ratio. So I think if you are teaching people with a piece of string to make approximately the right thing for the golden ratio, 9 and 4 and 9 would be far, far easier to teach people than these kind of bizarre ratios that would be very, very difficult for people to learn, okay? And so 26.56. If you then, thank you very much, DIY Projects with Chouts, it's very, very kind of you. So if we look at Zeiss, his is even more out, okay? So I kind of feel sorry. I hate to have to do this. I almost hope I'm wrong. but Zeiss actually named his book 76.345 degrees, and it's the furthest departure from what is shown at Abydos in writings there, and it's further from the experimental teaching. And so, you know, I think that I'm going to run with, and unless anyone has any great objections, I'm going to run with from now on that Robert Hutchins here is the correct ratio. And here is the original. Okay. And I also have the experimentally derived structure here. And this was the old disruption zone, but you can see a disruption zone is anywhere within this area. So you can have a disruption zone here. And we do know that it was like ellipsoid in both the Binger and Huang DHX2 data from flux capacitor, and also in the cavitation in water of Suhas-Ralkar. So I've shifted that for a modified version, so the experimentally derived, this is the modified version, so it's in position, and this would be the disruption zone. So that is what I'm going to adjust to and in moving forward. Okay, so with that, I want to talk now about the 48. And what we learnt from the Vega Valley sample here by Henk Urian. And what I will note here is that all this debate about how big this triangle is here, you can actually see that the inside of the sothis of the triangle is actually much tighter. The caduceus that comes in, it's much tighter. Okay, but this is kind of like the outside zone. So from this diagram, you can imagine that the cone here is just going to move out slightly, very, very slightly. Okay, and it will affect the subtors as well. Now, the important thing here when we're talking about the subtors is in this one we're showing two. Okay, and they are constructed by a sacred geometry structure also, and the inner tor here of the n-1 tor is made by n-2 tors, and they are, in my view, on the golden ratio line here, and they similarly will have a sphere in the center. So there's two very clear n-1 cores here. This one here, which is coming out at this very specific angle, and I will discuss this more in relation to ancient things that I've seen recently, megalithic structures, and also that I've seen in various experiments, like if we actually go back to, whilst we've got it in the system here, the output here on this structure is also coming out here. It's this is like a strange radiation, a vortex going around. It's, you know, two things spiraling around each other on this top right corner here. That's the same angle that's coming out of, in my view, what we're seeing in this Vega Valley ball lightning breakup. Okay, now this is the head of the caduceus, the sphere. This is the ejector. The ejector was probably lying over here. It's kind of like rolled itself round, but it's got a flat cut there, and that flat cut would be marrying up to the top of the caduceus here. So this kind of flew out and came round here, came over here, and then flipped over. Okay, but it seems to have carried it, the n-1 core from this side with it, and it's orbiting around here like a little moon around the Earth here. Okay. These structures are what we are going to be focusing on when we look at what the 48 is coming from. And I have to load another object, and hopefully this one doesn't crash it as well. Okay. So load. It's a much bigger object. Okay. So what am I talking about? Well, this disruption zone circle should be shifted up in our new understanding, and this cone should be slightly larger to match with the Robert Hutchins sacred geometry golden ratio cone angle. Okay, so what we have, if we look here, there's the main tor on our structure. Okay, so if we go into looking at this in 3D, that's our main tor. Okay, and our n-1 tors are revealed if we remove our main tor, and this is just in a 2 subtor structure. Okay, I'm going to change this to wireframe texture here. This is fine. Okay, thank you, Bob Wildfish. That's really, really helpful. Thank you very much. Yes, I did do a presentation on that book. I think it was called Disruptive. You may like to look it up. And I addressed some of those concepts. I only had a chance to briefly read your comments. So Bob Wildfish made a really good comment and on remote-view.icu. So thank you very much. So here we have the subtors, and what the sacred geometry that is necessary for us to do what we need to do to analyze this 48 is here. And so if I actually pull that in, you can see that here the subtor actually, and what I've done is I'm not rotated this 90 degrees. What I'm trying to do is show, if I actually put the yin cone into the background here, you can see how this is organized here. So if I actually go like this and I zoom into that and I go like this and I go like that, you'll see a bit better what I'm talking about. So what we're looking at here is the substructure here, yeah, the substructure and the sphere that produced. So that is this sphere in this substructure, yeah? It is this sphere that's orbiting around the n-level Tor sphere, iron-rich crenellated sphere in this case. This might be iron-rich, but I think it's likely to be silicon, but it might be iron-rich at this level. It depends on the strength of the overall structure, in my view. So this is the subtor sphere, okay? And that has a scale that is essentially the same as the subtor diameter. Okay, so essentially what we want to do is look at what happens when we make a 48 rotation around the outside of that. And I did that, okay? And this is what I found. That when you do 48 divisions, right? Yeah, around there, okay? 48 divisions, they interfere with each other, okay? But it doesn't quite work like that because we know these spheres are hollow, okay? We know these spheres are hollow, right? And so there will be a thickness here, okay? So if the thickness is above a certain level, then they would still be able to exist, because if you looked at the work of S.V. Adamenko, he shows that a dark matter area inside is what does the transmutation. And I believe that the coherent matter is in there and it is ultra dense. And you can see this in flux capacitor, where out of a one of these structures, a vast amount of material comes out, just like it comes out of a sphere in Takaaki Matsumoto's work. So you see a huge plume of carbon coming out, and that was all inside that sphere. It's a much larger volume of material coming out. So it's coherent in there, but it's incredibly incompressible, okay? It's compressed by the toroidal moment and how that acts upon that structure. And when the toroidal moment fractal toroidal moment structure collapses, the material is unbound from that containment field, and it literally erupts out of the weak point. Okay, so I'm pretty sure that we have a boundary in there, which if I was to draw it just a little bit tighter in, we would see something like this. So if I actually get rid of our sacred, our yin cone here and our sacred geometry here, this is kind of what I'm thinking about. And so we know these things are hollow. And so the incoherent matter, and I believe actually even this layer here is coherent whilst the toroidal moment is acting. Okay? I believe that that is coherent when the toroidal moment is acting. However, it becomes decoherent and it forms this wonderful kind of crenellated structure if the sphere is big enough. So if you just have this thickness, then the internal compressed material does not interact. And so still this thing could be stable. And you could imagine if you had more circles, more tores, then it would get harder and harder because the interaction area would be larger and larger. Okay? But it doesn't quite work like that, does it? It works like, if we show it here, and we want just the yin, right? We want it in the background. And we want it like this. And like this. So, what I'm actually referring to here is that we're still looking at this as a 2 subtor structure. But then we've drawn in the cores of the subtors for a 48. And we know it doesn't look like this. It looks different. And it looks a little bit like, well, it's squished, essentially. It looks like this. If we look at it in the full geometry, it looks like this. You'll remember this from 2020. Okay, so these are the subtors with 48 subdivisions. And what I've got over here is I've put in the yin of a normal one. Okay, so there's a normal one that's squidged in there. Okay, but they should be pinched. Okay, they should be pinched. Yeah? So if they're pinched, then you could imagine that the core in there might be slightly distorted too. And if it's slightly distorted, what does it look like? If you distort the sphere the same as the tores are distorted, then the outer edge of that is where it would ordinarily be from, like, as I drew it earlier. I think basically what happens is if you go more than 48, the how should we put this? The field structures interfere such that it cannot maintain the dense structure inside, and rather they're so dense that then it can't reorganize again and it just pushes itself apart. It blows up, as John Archibald Wheeler would say. So I think there's a limit to how much you can squish this, and this is the squishiness of 48, and I think it hits the limit when you're doing that. Okay, so it's a little bit rough in in my thinking. But I think essentially that is it. You can't have the hollow spheres at the n-1 subtor level survive beyond 48 divisions. And I think it's to do with the degeneracy or something of the n-1 Tor fractal toroidal phase singularity area. And that is where I'm thinking at the moment on that. And I would like people's opinions. Does that sound reasonable to you? Does it sound like nonsense? You don't all have to agree with that last sentence. But if we go here, this is kind of what it would be if you had no distortion at all. It would look like that. So the red area here is the outer zone, which is your normal n-1 Tor sphere. So I will go here and I will put in that. So you can see that would be your normal n-1 Tor sphere. And I will put in the sacred geometry as well. Okay, so in the background there, so you can see how that fits in. Okay, that would be your normal, although the sacred geometry should be rotated 90 degrees. But I've just done this for purposes of showing you the fact that this is the correct size. And so there's a limit. Okay, 37 probably fine, 47 probably fine, but your 48 is on the limit when you start to distort this. And the distortion comes essentially like that. So does anyone have any questions with that? Okay, Gordon. Yes, it's a squash bagel. Well, we know that it squashes like this. We know 100% it squashes like this because of what happened in the Hutchison sample. We physically saw that from which it was derived. So wherever it is, do I have it here? I don't know whether I do. Yeah, here. In the Hutchison sample, the outer radius of these things to the inner radius was bigger on the outside and smaller on the inside. So that gave me the understanding that I needed to produce these pinched areas here. But of course, the overall pinching will change the field structure. So if this overall field structure can distort, you would imagine the shape of the n-1 Tor would be distorted from spherical also. Okay. And so that is the logic that I'm using. And I'm saying that there's only so much distortion it can go through before it becomes unstable. And I believe at 47, you don't really have a problem. But at 48, you're hitting a hard limit. And going beyond that, the thing will fall apart and go into subquanta. Okay. Yeah, something like that, Gordon. Yeah, so he says it will likely lead to each disk to be squeezed outwards, breaking the integrity of the outer bagel. Yeah, quite possibly. What might be the ramifications of the gaps around the outside? What do you mean? Yeah, so D2-105K surpassed 48, it would tear it apart or not form into a torus in the first place. Now, I think how these things build is, you know, if you look at the presentation from Cosmic Summit, which is iterative from other presentations that you've seen, you know, we see in the plasma hot tube, which we want to create into a direct matter to energy device, the torus here is stable for a while, and periodically it'll flash and it departs from there. And then when it hits the fused quartz, it leaves like, this is a swastic one. This is a 5-order structure. This is a multi-order structure. So I think if you energize it for longer and longer, it sub-orders and n level and n-1 and n-2, these are reorganizing all of the time. It's not clear from Bostic's work very much what the subtor structures are. It just simply wasn't clear enough. But certainly you could see the n-1 tors in Bostic and Nardi's work. In the 3D representations of the structures, of course, we got a little bit more insight into that. We have an n-1 tor here, appear to be just 2 or no more than 3. I think it's 2. Over here it's 3. Over here it's 6. Okay, so you can, and this would have been 48. So this would have been 48 divisions on the n-1, and the n-2 had 6 divisions. Okay, this would be whatever it was, but the n-3 or 4 in this case, because this is very small, it's only 500 nanometers, the scale here. This only had 3 tors on the substructure. Okay, so it's basically self-organizing, and when it gets more energy, it will reorganize into a different configuration, and then it just, you know, if it gets to 48, I guess its only choice is then to divide that into 2 subtors of 24 and make an n-level tor that's much bigger. And if it can't do that, then it falls apart. It breaks up. Or maybe it breaks into 2. You know, maybe this is what you're actually seeing when you're seeing a branch in lightning. The ball lightning, the thunderbolt at the head of the the lightning as it's making it, right? It gets too many tors in there, and it splits into 2 tors, and it makes 2 branches, right? Or it splits into 3 tors. These things are very good when you break them up to self-reorganize into self-similar structures at a lower level of complexity. And so I think maybe those kind of things are going on in lightning branching, probably even going on in Townsend avalanches and all these kind of, you know, what do you call it, Lichtenberg figures and all these kind of things. There's something similar going on where, you know, it builds up a certain level of energy and structure, and then it becomes unstable and breaks up. Okay. It's probably why a unipolar arc from a Tesla coil looks like a unipolar arc. It like has a bit coming up and then it has tendrils coming out. Yeah. Yeah, so it's kind of how I imagine these things. They form in a certain way by reorganizing. You can imagine it's just, they're all reorganizing into all kinds of beautiful regular arrays that have a minimum energy surface and minimum energy overall structure and are as organized as they reasonably can be given what's coming in at them and their overall environment. But, you know, if you push them too hard, they fall apart. And I honestly think that this is why the ARV had 48 divisions. I think that's why it you know, that's allowed it to be stable. And, you know, this has the phi ratio going in, you know, with the original Ukon of Sara from Helsinki, copied by the Tesla logo. The outer part here comes in, and it comes in on the phi ratio because you've got the n-1 cone coming towards the camera, or going away from the camera here. And so the logic follows that it just would be like this. You know what I mean? If you're seeing the spiral going out and coming in, as it were. So it just, and Tesla has this, it's not a proper circle. It's a circle that would allow for a vortex to come in and form what it thinks is the right form. And you know, so precise Wardenclyffe Tower in terms of its engineering. And these hemispheres to provide minimum surface curvature, and it's a torus built of hemispheres. So you maximize the surface charge on convex surfaces. Okay, it's just a thing of incredible insight and probably a lot of hard work to get to that point. Okay, so yeah, 48 round here. It's logical. Now, as I said, you know, we know from experiment that for certain that here outside, so you got a 4, 2, 1, and then this is 1 divided by 1.618 to give you this circle here. But on the 1 level, which is one of the main parts of the magnetohydrodynamic structure, you have this material here, and it's got an event horizon, an absolute 100%. It's swept around there, but there's none inside, and it's outside. It's an event horizon. And I'm saying when you spin it up to a certain degree, not the most amazing degree, but a certain degree, you will have the ability to have the flux of relic neutrinos coming through here at such a rate that it counteracts the cosmic flux that's trying to come down and push it towards the Earth. And at a certain level of organization of the relic neutrino condensate around the structure, you are going to get the inability of this craft to fall to Earth. And it floats at this height, which is defined by this drawing by an artist who is trying to sketch out what was being described as from one person that saw these things in a hangar. Okay? So that's it. So in summary, we have worked out that there were the original proposal that was derived. So this is O'Day, 48 and cone. This was the original cone that I derived from experiment and my estimation on where the disruption zone was. I just chose a point relative to the data I had within the sothic triangle's notch. The sothic triangle is here, and it has this very easy to describe, to tell masons what to do or whatever, which is 9, 4, 9. And essentially you need something that is 22 units long, and you have 2 pins that are 4 units apart. And then all you do is you just move it so that the joining of the 2 ends of the string is directly above the center line between these 2 4-unit apart things. And it's that makes it incredibly easy for you know, a stonemason to work out what they need to do. And the ratio from experimental determination came out at 2.286, let's say, which is 1.573 out from the ratio as described. However, I do believe that Hutchins, which is a little bit more out from this, and I basically think that this is just a draftsman's estimate, is compliant with how a sacred geometry, the golden ratio is shrinking. And so I believe that Hutchins is right here, Robert Hutchins. And Zeiss, unfortunately, sorry for his book with his 76.345, is too far out from the ratio and experimental observation. Okay, and I did the hard work to model this in 3D to assess this. This was the original here. That's the original. Okay, that is the original. I have the Robert Hutchins here, which is, you can see it's a little bit outside. And in the case of Robert Hutchins, he's going through the diameter, which we want to do if you are a spiral vortex coming in, shrinking at the golden ratio to hit exactly the diameter at one sort of unit or one golden ratio shrinking step. But I would like Robert Hutchins and Charlie Zeiss to actually hash their thoughts out on this. So Charlie Zeiss is the furthest from the kind of like Abydos type description. And so I think I'm going to go moving forward with the Robert Hutchins one here. Okay. And then we talked about the experimental evidence here of the accurate top of the caduceus circle being absolutely correct as per my interpretation, and it was always this interpretation and nothing other, from the original slide 91 in my original January 2018 presentation, which I did not know until I was assembling this variant of slide 91, which had these two better images. The original slide 91 had only this image on it. I did not realize that this was carved by Coptic Christians until a few days ago, but it makes complete sense with what we have learned since. Okay, so everything follows from that, and the experimental data here is very, very strong in my opinion for how things should be arranged. And this is the N-1 core. And from that, I believe the understanding that I'm presenting to you today is that if you have these two arranged like this, it's quite difficult. It isn't like this. Let's start that again. We do know that the spheres are hollow. So just on this basis alone, you could imagine that the ultra-dense coherent matter inside the hollow part of the sphere, which is confined by the toroid around it, the toroid being this kind of toroid around it, it is not going to bleed out, but it's not going to want to interact with something right next to it. And so if you push it harder than 48, you will have distortion here. But if I go like this, maybe, I think that the distorted structure here, and this is the inside core. So I've got the outer core here. Sorry, the outer core. Yeah. Let's get this right. The outer. This is the outer when you're just taking the normal sphere and cloning it 48 times radially. The inner one looks like this, okay? And that inner one is effectively the same diameter as the squashed outer one. So I'm saying that when the squashed outer one becomes incident with the inner one, then you have an instability situation and the thing falls apart. I think the inside is much less forgiving of being squashed than the outside. That is my hypothesis for now. I would welcome anyone else's hypothesis. And so I reckon that is why you have a limit of 48 on any subtor. Okay. And that, my friends, is what I wanted to share with you today. And I will put in everything for the sake of just having everything on one page. We will put in the Robert Hutchins scale here. So we can go right the way into that and we can see all of those scaled structures, and we will put in the overall original material here. That's the experimentally determined, and then I modified it here to move up the disruption zone to the golden ratio point, and that is essentially that. So have you got any questions? If you've got any questions, I'll take them now. Hi, Phil. So Phil, if you just joined us, welcome. And what I've talked through here is that Robert Hutchins is probably correct with his determination of how the cone is shaped. It's the closest to the work that is in Abydos, the sothic triangle. You can go and review that. And I think we have a working understanding of why we can't go beyond 48. And I think these are some of the last things to resolve in the fractal toroidal geometry. So Bob Wildfish, are you publishing the 3D models? I'd love an STL. Okay, so the guy that helped me produce the 3D parametric builder for fractal toroidal structures as a Python script in Blender. He's primed and ready to receive my final kind of working model to produce a Blender script that allows for building the full structures with their disruption zones and their subtor structures and cones for multiple fractal subtor levels, so that you can easily create the geometry of the flower of life, of the swastik, and these kind of things. The things that I've been sharing in recent presentations, you will be able to build them parametrically in Blender. So that's the idea. I will put out some. There has to be some way to help my wife and I pay my bills. So I will put out at some point some T-shirts with what I would say are my official understanding, until the facts change, of what I think the structure is, both as 2D graphic art and as some 3D graphic art, maybe with some interesting catchphrases. I would be interested for people to vote on particular catchphrases or suggest some. I know some people have said them in the past, but they will be available probably on one of the dropship places. But I think we're in the final stages of understanding what this is. It's nice to have had the contribution from Robert Hutchins and from Zeiss and from that's Charlie Zeiss and from Gabby Ensign recently. I think that is all informed and helped settle what is actually going on. I'm probably going to do a Vortex one on here to check and to verify. Thank you, Mark Dame. That's very, very kind of you. It really helps. Alex Lersman says, this may not be the time or place, but I believe alternative energy needs its own special crowdfunding platform, maybe including crypto. I do know that there are people thinking along those lines. So Bob Wildfish says, I'm happy to buy the Blender files once they're made. Oh, they won't be for buying. They'll be for free, right? So, but, you know, I will make a selection of things, you know, of the basic structures. And Tobias, yes, it's literally in your face. Thank you very much, Verity Hound. That's very kind of you. Yes, this will help. I've actually, I've got Jordan Collin over here, and he's helping work through the Matsumoto material. We found a good proportion. I mean, we literally have very, very, very large number of, I'll show you here, a very large number of packs. And these are for, and you can see the experiments that he bound up here. These are S14, S16, S21, S33. So these are the photographs, sometimes of SEM, sometimes of, you know, under the microscope. Thank you very much, Black Tie. Thank you very much, Claire Westwood. That's wow. Cheers, guys. I will work towards animation. And in fact, my intention is the new version of the software that you see on the screen here, Lightwave. I've literally bought the last 3 versions and I actually haven't used them because I use this thing called Lightwave CAD, which gives me all the sort of top-end tools that you get in the CAD software, which enable me to do all the extension and do this work to verify whether Zeiss or Ensign or Hutchins were correct, and really drill down on that. The new software has better fluid dynamics. It has the same fluid dynamics that I have in this software, but it also works with O-tools. Interestingly, what is it? Anyway, it's a software that produces very good visuals. So what I intend to do is use the best understanding I have of the subfractal tors and try and create a finite element analysis kind of semi-ish attempt based on matching what you physically see in nature. So what you physically see, for instance, in what actually goes on when you do an experiment. So if we look here and we look at this, by trying to match the flow pattern you get here and here, this is in non-charge separated material, this is in potentially charge separated material, or at least polar. In these particular images here, you're seeing the flow pattern. So I will target a simulation that will produce something that looks like this on one tor level, and then see if I can deliver an overall pattern of what a fractal toroidal structure is doing in fluid dynamics, probably with only 4 sub-tor structures. I think that's what I want to see. I want to see if by fractalizing a single fluid dynamic structure and then just a straight tor and then making it into 4 subtors, do we actually see what we actually observe when we are looking at, say, the 4-tor structures and the 3-tor structures and the 5 and the 6-tor structures that we see here. So these 3-tor structures, do we see a vortex forming? Okay, do we see a vortex forming in 3? Okay, when we go to 4, or when we go on 2, do we see these beams coming in? And do we see on a 4-order structure, do we see the beams not escaping? And so these are the questions that I would like to see if a simulation can show. Okay. Corky says AI has some catching up to do. Yeah, well, AI will probably tell me some point in the future what I've already said. and it'll be very exciting, not really. Claire Whistle said, the plasma entities are so proud of you. Well, this is a huge team effort. This has required scientists from all over the world to allow the project to come and visit them. And the project has only been able to visit those scientists and been able to do the analysis because the crowd has supported that work through donations, big and small. And so this is a complete team effort. It's just I happen to be the one lucky enough to do a fair proportion of the work and be in a position to bring some of this data together. I do feel all the time the luckiest person on earth. I was telling someone when I was having my lunch earlier today, you know, this is the best job in the universe, and you know, I have to do it, but I'm not sorry I am. So and it's just great that I have the support from you guys and the support from the crowd. And if I'm wrong, I'm wrong. But you know, I think we're getting less wrong as we continue to work. You know, as the old phrase goes, the harder I work, the luckier I get. That kind of thing. Yeah, thanks, Black Tie. It really means a lot. Yeah, so Corky, you want to do the animation. As a person who ran an animation business for most of my paid career and the graphics design business, I'm itching to do the animation, but there were things that were not settled for me. And I think those things are iterating down to a solution. And, we can kind of agree that, when third parties out there are showing you things that are mathematically derived or derived from looking at sacred geometry alone, and they're getting quite close to what is observed in nature and what is written in ancient texts as the way to do this, then we're converging on a solution. And you know what? I think probably if you set up a scenario where the fluid dynamics was constrained to an environment which was 16.9, or at least roughly, with a little bit of leeway, nature would take over and fill in the gaps very, very quickly. It would just do what it needs to do very, very quickly. Thank you Verity Hound. She says she'd like to help on some podcasts. I do need to find a way of upscaling the information as the information becomes clear, and the replicability of the experiments becomes easier and easier, and more people have done it. Then it is going to need the information packaged into really, really tight and very, very accurate and well-referenced pockets of information that can be bite-sized and really easily absorbed. And so it's going to need coordination and assistance, really, because there's so much you can do, in my view, with this technology, this catalysis all the way to nucleon decay. Catalysis is kind of like lowering the energy threshold for a chemical reaction to occur, but there's even weaker levels than that. The failure of an ionic bond or a metal bond, the weak metal bond between crystal grain structures. So, yeah, bite-sized bagels. Yeah, yeah, I like it, Gordon. Cool. Alex Lozman said, I paid a guy to make a dope rap about plasmoid fusion for $50 on Fiverr. Excellent. Oh, I look forward to hearing it. All right, so with that, I think probably I'm going to close out for tonight. I will share the basic geometry images and the the kind of things that you're seeing here. Kind of nail down what we're talking about here. I am keen to understand if people have another view on what is going on with why it only appears to be 48. I kind of had this mental image in my mind that it was something to do with the degeneracy or the maximum level of compression of condensed matter. When the Earth is collapsed into a black hole, the black hole is 12 millimeters across. It isn't 1 millimeter across, it's 12 millimeter across. I think it's something to do with a Schwinger limit. And maybe the Schwinger limit is coming into play here. I don't know, but maybe something like that. Or in this process, the fractal toroidal moment can only compress matter and keep it condensed in a quark-gluon cluster. Electron nucleo macrocluster in the terms of SV Adamenko. You can only keep it there at a certain density, and when the toroidal moment structure, the fractal toroidal moment structure collapses, it just spews forth, and that causes failure. And I think that's what's going on. All right, so thank you very much. It looks like Terran Earthlin says it looks like a form of flying saucer propulsion. Perhaps you missed the Cosmic Summit presentation and other presentations where I walked through the basis for this and the fact that you have literally a paper by NASA which is describing in 1979 all of the properties of UFOs, and saying that if we do a current loop, this is a 6 Tor n-1 Tor structure, we end up with magnetic reconnection, and the magnetic reconnection ends up with a phase singularity of a defined size, and the phase singularity is what causes the Aharonov-Bohm effect, and they're saying this is for intergalactic travel, and it is a fractal toroidal moment structure. There's no doubt about it. And this work here shows going to a phase singularity, right? This is published in mainstream journal in 2021, but it's replicating 1976 work that is quoted in this 1979 paper, okay? And maybe you missed the fact that I was showing that this is the structure that makes the ARV, in my view, work. And it works by having a counteracting flux of relic neutrinos that is able to nullify the flux that's coming from the cosmos. And it literally, when it's spun up, the structure is, the process is spun up to a specific level. It has a toroidal field in there that's able to maintain levitation indefinitely. Paul S.G. Tree says, you said the inside spheres were hollow but dense. Dense meaning what? I mean dense in terms of electronuclear macro clusters. Okay, so if we've got, if we have the front cover here of Takaaki Matsumoto's Steps to the Discovery of Electronuclear Collapse, and by the way, we're going to be able to upgrade all of these images. You have this sphere, and the sphere is hollow, and out of this hollow sphere, all of this carbon has spewed. Okay, so you've got to imagine all of that carbon is in that sphere when the electrodynamic fractal toroidal moment-bearing structure, fractal toroidal electrodynamic structure, is confining it in there with the lead on the outside. The lead is the starting material, the carbon is the synthesized material. Okay, so I believe it can only compress so much baryonic matter in there in a coherent state, and then it reaches a threshold, and then, you know, maybe this didn't reach its threshold, but regardless, when you remove the confining fractal toroidal structure, it will spew forth probably the level of resonance that's going on in there. Okay. Yeah, it's not a singularity. It's definitely not a singularity. Yeah, it will spew out, I wouldn't say molten metals. I would suggest it would be metals that are in a state of jellification or non-thermal fluidization. And it's due in part to, there's several ways you can achieve that. If you do it with the Yang force and you extract energy from the hidden energy within the matter, I think the matter will become more dense in its own right. If you over-energize it by putting more energy into it, more chi energy, it might fluidize without becoming hot. So, you know, these kind of things. Yeah, the sapphire reactor is clearly the same thing. Yeah. I have suggested after watching the sapphire presentation, but I basically, it was a thought that I'd had for a long time. I just wanted to get it out that point, that I believe that solar systems are built with this basic technology, or rather you can use this technology to build solar systems. Yes, it could be a tractor beam. So, you know, in the tractor beam, when you have one of these devices, you automatically get a tractor beam built in, and it will be under here in the vector of the flux of relic neutrinos. So it's very easy to understand how the tractor beam would work. So, since you asked the question, let's explain that. You are being pushed down onto the Earth by the relic neutrino flux that has to go through you to go to the condensator, which is the Earth itself. And that's why it grows, because it condenses 2.25 electron cold neutrinos into 938 or whatever it is million electron volts, protons, neutrons, or whatever. Okay, so it's like a steam engine. The steam's converted into condensed water, and it reduces by 1,716 times. But in this case, it goes from 0.25, and so you basically, if you take 938 and divide by 0.25, you get a lot more than 1,716. So it's condensing that. It is therefore a gravitational well. The cosmic flux of relative neutrinos then goes through you and pushes you onto the ground. Now, inertia is the same thing. You have to work through that. And so if you have something that you've got enough flux of relative neutrinos to levitate your ARV here off the ground, if we're flying up in space and we modulate our beam that comes down, and you have another thing in the way of that beam, it will naturally be pulled up into the device. And so, you know, it's fairly trivial, because you're going to have it's the opposite of gravity. So the flux of relative neutrinos is pushing all of the matter in your body up, or all of the matter in your car up, or all of the matter in your 36-wheeler or whatever. You see these videos, like there's one very famous video where a tornado is traveling over a landscape and it goes past a parking lot full of very large haulage trucks, and the trucks, the cabins are lifted up very slowly, moved a little bit, and gently laid down. And I would argue that in that case, the relative neutrino flux was sufficient to overcome the natural flux of relative neutrinos that is trying to get to the condensator, which is the Earth itself. And so it's just the counter flux, and we know that the tornado, in my view, in my opinion, is the same kind of structure that's doing all of the work in all of these systems. So it will naturally be able to negate the mass which is holding that truck metal on the ground. It'll just be able to lift it up. Do you guide the vehicle with magnetic pulses? It's very simple. You have phasing around and you have phasing up. So it has 8 capacitor plates here, and you can oscillate the charge on those up and down on each of these capacitor arrays. And you can see they're kind of arranged alternately. So it might actually be this 24 alternate, and you might have one phasing up and one phasing down. And by doing that, you lock it, but you might want to phase one slightly up a little bit more than the down, and so you have a net balancing of the flux that is gravity. Okay, and then you could also phase it round, but I don't think you need to phase it round. What you can do is you can increase proportionally the speed of phasing up and slow down on the other side, and this matches precisely the control mechanism, which is a hemisphere like that, and you tilt the hemisphere here. It's here in the control mechanism, and that will just be shifting the rate of change of the phasing here, which will move the fractal toroid that is around the structure, such that you spin the ether, and then the ether persists spinning like a superfluid, and that moves the charged particles that you need to do the work. Okay, and of course in the air and in water, those are already available. And if you want to work in space, you need to work directly with the relative neutrinos, or you can push against something with the British Railways Board patent. They had the capacitor arrays underneath, and they had a nuclear reactor producing particles. So this would work in space as well. But again, it's using similar principles. Okay, this one is principally for working in space. The JF King device, where it's ionizing the air, producing the charged particles, and then you phase these corona rings to do pitch and yaw and give your vectoring. So this is a very, very, very simplified look at really kind of how this would be working in a much more complicated way. but they've divided these up so you can have both phasing up and phasing down potentially simultaneously. And so you have tight control on whether you're vectoring up, vectoring down, or tilting. Yeah, so I think we're going to be able to make a device that looks a little bit like this. But you know what? I'd really like it to be run steampunked. It would be great if the whole device was just run steampunked. But probably we're going to need to have a homopolar generator in there, and we're going to need to have a high voltage device, and we're going to need to probably have, unfortunately, because there's not many good ways to do it otherwise, a magnetic a mercury contact-based system, because it can carry the very high currents that are produced by a homopolar generator. But anyway, there's something more interesting that I will come on to at another time that's going on with a homopolar generator. So there's no homopolar generator in here, but there is in this pattern, and there is in this pattern. Curious. And the homopolar generator is very good at generating very, very high currents at low voltage, which is the direct opposite of a Tesla coil, which is creating extremely high voltages at very low currents, okay? But that is not what I'm interested in. And I will talk about what I'm referring to when I go on to do a more detailed explanation of how something like this might work using the understanding we already have now. And that is it's to do with what happens when you're spinning the metal, not the current part, but other things that are going on. And it starts to make sense why other things are in the device in the place that they are. Anyway, that's for another day. It's been a real pleasure. It is now 1:20 in the morning. I need to get to bed because I've got a lot of work to do before going to Strasbourg, which I will be in this time next week, having attended the reception. And I need to do my presentation for that, which I think is going to be extremely critical because there was something else I was going to share tonight, but I'm going to share it at Strasbourg. The paper with Binger and Huang is literally a watershed, and it's really going to change a lot, in my view. But I think we can have power systems for producing heat predominantly, and I think it will break the back of disbelief that's going on in the West. So I think we're really at the new dawn of an old age, and we have been, you and I, and the other members of the MFMP, and all of those scientists, both present and long since past, we are lighting the new fire together. So with that, I will say, thank you very much. Buenas noches, dobranoc. Good night.